Hello, and welcome back to New Scientist Weekly, your curated selection of the week's science stories. I'm Timothy Revel in New York.
And I'm Christy Taylor, also in New York. This week on the show, the discovery of a massive ancient city in the Amazon with help from lasers, plus a new solution to Hawking's famous black hole paradox, and why some coral make a habit of changing their sex.
And what if we could have all the power of lithium-ion batteries, but with 70% less lithium? AI may have found a way. But first, we've got new insights into how the brain changes during pregnancy. It turns out that almost every part of the outer layer of the brain, called the cortex, thins out and loses volume by the time someone is in their third trimester. But most of these changes also reverse after they give birth. Our health reporter Grace Wade is here with more. Hi Grace, welcome to the pod.
Hi, thanks for having me.
So Grace, this is such a profound change in the brain, but I guess that makes sense because pregnancy itself is a profound period of change in the body. How did the researchers go about measuring the cortex throughout that period?
So the team used MRIs to image the brains of 110 first-time mothers, once during the third trimester of pregnancy and again within a month after they gave birth. They also imaged the brains of a separate group of 34 women who had never been pregnant or had children before. And then they looked for differences between the two groups and found that pregnant women had lower cortical volume and thickness across all functional networks compared with women who had never been pregnant. These differences were so distinct that you can tell just by looking at someone's brain whether or not they're pregnant. And no one has ever looked at brain changes during pregnancy before this, so these findings were really surprising.
One bit I found particularly surprising was the way that some of these changes actually reversed in the postpartum period, but not all.
Right. When they looked at the brain scans collected from participants after birth, they saw that most of the thinning had become less dramatic. So there weren't these stark differences in cortical volume or thickness between the two groups. However, the thinning remained in two brain regions, the default mode network and the frontal parietal network. They stayed affected even after pregnancy.
So Grace, what does this all mean? Is there a function for these brain changes during pregnancy?
We need a lot more data, but there are some theories. One widely accepted idea is that the brain undergoes changes during pregnancy and birth to prepare for parenthood. So cortical thinning also occurs during adolescence, and this is because the brain refines neuronal connections during puberty. Essentially, it's turning a network of winding country roads into an efficient highway system. So some roads get closed off while others are transformed into an 8-lane highway. Something similar could be happening in pregnancy. The default mode network is a region important for self-perception and social interaction, and the frontal parietal network is critical for executive function. So, things like planning and carrying out tasks. So it would make sense for the brain to refine pathways in these regions to facilitate empathy and connection with the child, care for the child, and also to have parents see themselves as parents. But that's probably only one factor. There's likely something else at play, especially during pregnancy when changes are so widespread.
Is there a bigger picture beyond seeing the brain get thinner and thicker in places? Some benefit to understanding the specifics of how pregnancy might affect the brain?
Absolutely. Understanding how the brain changes during pregnancy could help us better understand neurological and mental health conditions associated with pregnancy. For instance, about 20% of those who give birth develop postpartum depression. If we know how the brain changes during and after pregnancy, maybe we can better understand what causes postpartum depression and how to best treat it too.
Michael LePage is here next. Michael, this week you've reported on the discovery of the largest pre-Columbian cities yet found in the Amazon rainforest. That is the largest urban area before European exploration and colonization began. So where are we going exactly?
This is a discovery made in the Yupano Valley in Ecuador. So the valley is in the foothills of the Andes, but it's part of the Amazon rainforest still. Back in the 1970s, a priest there discovered traces of pre-Columbian settlements, and there have been a few excavations since then, but the area hasn't really been studied much.
Okay, so this is a site that we've known about for a while, but we didn't always know how big it was. So what changed?
So what changed is that one of the teams did a LiDAR survey of the area. So that's where you fly over an area and you use lasers to map the surface of the ground. And what it's revealed are the earthen foundations of thousands of buildings with a network of roads connecting them and lots of fields with drainage ditches around them. So just in the area that was surveyed, there were 5 major settlements. These could be called garden cities as the buildings were quite spread out, but it's a very large urban area. In fact, these cities are not just far larger than anyone realized. They're the largest pre-Columbian settlements ever found in the Amazon region. And they date back a couple of thousand years.
That's incredible. And I love the idea of a garden city personally. Can I live there? Um, but so that's just been sitting there all this time waiting to be discovered. How did we miss it? Why wasn't the extent of the site realized before? Just seems something that big would be difficult to hide.
Well, you'd think so, but we're talking here about structures that were made of earth and wood rather than stone or bricks. So once those wooden buildings rotted away, all that was left were the earthen platforms that they were built on. And once those earthen structures were overgrown by vegetation, their shape was obscured. So the largest earthen platform found in the Upana Valley is 5 meters high and 140 meters long, so it's pretty big. It's thought to have been the site of monumental buildings used for ceremonies. But you can imagine once it got overgrown with trees, it's going to be really hard to spot if you're walking through a thick rainforest.
You mentioned that there were roads as well. Was this a pretty well-connected area?
Yes, so we're talking here about simple roads. These were created simply by digging out soil to level the surface. But there are a lot of them, and the longest extends for at least 25 kilometers. It could go on further beyond the area that was surveyed. So the really odd thing is that the Upana people went to a lot of trouble to make their road straight. So in places, for instance, rather than just following the contours of a hill, they dug down 5 meters. So that was a lot of work for a sort of pre-industrial culture. So Stephen Rostein, who's the team leader, he thinks there might have been some symbolic significance to straight road. There's no practical reason for them to be straight, he told me.
Interesting little mystery. And if these are the largest pre-Columbian settlements found in the Amazon, does that mean there are others too?
Oh yes, absolutely. So there's been this widespread idea that the Amazon rainforest was largely empty and untouched before Europeans arrived. But in fact, there were farms and large settlements in many places. And it's been estimated that there were up to 8 million people living in the Amazon before Europeans killed most of them. That is, either directly or by introducing diseases such as smallpox. So a lot of these urban settlements were abandoned around 400 or 500 years ago, and the survivors either moved away or reverted to a simpler lifestyle. But what's curious about this Upana Valley site is that it's much older than these settlements elsewhere. So it was built starting around 3,000 years ago. It continued for more than 1,000 years. And then around 1,500 years ago, the entire valley just seems to have been abandoned.
Wow, so that's another mystery then. I mean, 1,500 years ago is well before the Europeans came through. So why was this settlement abandoned?
Well, as usual, the short answer is we don't know. But Rostein has found layers of what appears to be volcanic ash. So one idea he has is that there might have been a series of volcanic eruptions that forced people to move away to somewhere safer.
As we move into January, I hope your holiday season was full of good times with friends and family alike. But if you're looking for a chance to spend even more time thinking about how we're all connected, there's something already in your feed for that. Our Escape Pod episode of the week, which is all about alliances. From carbon's incredible bonding capacity to how lichen is never really alone. It's all there after you finish listening to the news, of course.
And next week, how about a journey to space? Reporter Leah Crane talked to astronaut Christina Koch, who is one of the 4 astronauts scheduled to circle the moon when NASA's Artemis 2 mission launches, which possibly may happen next year. It's all about breaking records as a woman in space, what space smells like, and why human bowling is the best fun you can have on the International Space Station.
Human bowling is where one person kind of gets in a cannonball position and someone throws them, and then the rest of the crew is sort of like the pins of bowling. And the idea is that you have to, bowl with your body.
Now, you may have heard that once something falls into a black hole past a certain point called the event horizon, it's impossible for it to get back out again. And it turns out that the physics of this process causes all sorts of problems for our understanding of the cosmos. But a new development might help us iron that out. Reporter Alex Wilkins is here. Hi, Alex.
Hello.
Alex, so this research, it's all about a famous paradox that Stephen Hawking came up with, right?
Yeah, exactly. So the late physicist was thinking about how the laws of quantum mechanics would work at the event horizons of black holes, those points of no return that we hear about so much. He found out that there'd be a kind of radiation emitted by the black hole, which is called Hawking radiation, which contains only some of the information of whatever is sucked in. This Hawking radiation would eventually cause the black hole to completely evaporate over time, And with it, the missing information about the thing would be sucked in, lost forever. But in physics, we know that information can't just disappear. So there's a tension there and a paradox.
I know there have been attempts to resolve this paradox before, but they always hit a bit of a snag.
Yeah, so physicists have come up with loads of really far out ideas to try and find out what happens to the lost information and resolve the paradox, as you say. But finding out which idea is correct normally involves diving into the black hole to measure it, which we both know you can't do. But recently, black hole researchers have found we might not need to enter a black hole after all, thanks to something called islands.
All right, first of all, I would say we haven't found a way to dive into a black hole yet.
Very true.
Second, what is an island in this very extreme physics context?
Yeah, so the concept of an island is a very mathematical idea, and it's nothing like what you would imagine an island actually is. But what we can say is in 2019, researchers found that for some specific simplified hypothetical black holes, there appeared to be regions on the surface of the event horizon, kind of like wedges on a sphere, which contain information about what's inside the black hole that's gone past the event horizon. And they called these entanglement islands. There was a snag though. These would reveal what happened to the missing information, but the distance that they poke out beyond the event horizon is smaller than the smallest possible length we can measure physical effects on. But now, two researchers at the University of California in Berkeley have calculated that for more complicated black holes, ones that are more like the ones that are actually in our universe, these islands could extend far enough outside the event horizon, as much as an atom's length in some cases for really large, massive black holes, that we might actually be able to measure them in our world without having to jump all the way in.
Wow. Okay, so this sounds better than nothing, but I would say an atom's length outside a supermassive black hole does not sound like the easiest bit of space to measure.
Yeah, you're not wrong there. So getting a scientific instrument within an atom's width of a black hole event horizon would require more advanced propulsion than anything we currently have on Earth. You'd also need a spacecraft capable of withstanding the intense radiation and heat close to a black hole event horizon. And to top it off, the nearest suitable black holes are thousands of light years away. So yeah, a few technical difficulties.
Details, details, details. Nothing that our best brains and a can-do attitude couldn't solve.
I also want my jetpack for black hole diving.
We'll see whether we can find the budget for that. Either way, this seems like probably the best chance at solving this paradox, at least for now.
All right, let's head to the tropical part of the Pacific Ocean for a look at some very adaptable corals. The hammer coral lives in single-sex colonies of either all-male or all-female animals. But it seems like some of those colonies actually change their sex, and they do it every single year, almost like clockwork. Sophie Bushwick is joining us to talk about what's going on at this underwater dive bar. Sophie just joined the New Scientist team as senior news editor based in our New York bureau. Hey, Sophie.
Hi, Christy. Hi, Tim.
Hi.
I'm so happy to be here.
We are also happy to have you, and for starters, just because this coral story is way too good and I need you to explain it.
Well, as you mentioned, hammer corals tend to hang out in these permanent single-sex colonies. And back in 2011, a team from the National Taiwan Ocean University was surveying some of the colonies, the ones in the West Pacific Ocean, and they realized, a lot of these have changed their sex since the previous year. At the time, there was only one group of corals known to swap sexes this way, so the observation was pretty unusual. And to learn more, the researchers spent 8 years tracking 26 different hammer coral colonies, and they found that about 70% of them switch sexes every single year.
8 years is a long time for an animal that doesn't move, I gotta say.
You just have to dedicate yourself to staring at the
Yeah,
coral.
yeah. Well, I know there are many cases of animals changing sexes in nature, but how common is it for a coral to change its sex like this?
Well, we think the hammer coral is the only animal known to change its sex on this regular routine schedule, but this type of flexibility or sexability is not unusual. Many coral species, as well as a lot of other animals, are hermaphrodites, so they have both female and male reproductive organs. There's also a group of corals that changes its sex on occasion, and at least one species that switches pretty regularly from releasing eggs to releasing sperm, though unlike the hammer coral, it actually has both sets of sex organs at once. It just activates them one at a time.
I'm always amazed by all the innovations in the animal kingdom. It's just incredible. But these hammer corals, they're the only ones we know who swap this way every single year. Why do they do it? What's the point?
I mean, that's the question. Other marine animals, they'll switch sex in response to changes in population size or in environmental conditions, but that's not what's going on here. So the researchers think the key is the way hammer corals live in those fixed colonies. So if you have a cluster of colonies in one area that's all female or all male, I mean, they can release all the reproductive material in the world, but they won't manage to produce offspring. So if some of those colonies swap sex on a regular basis, they have much better odds of finding a match.
Yeah, as long as everybody doesn't switch all at once and you just end up with the same problem reversed every time.
Oh, that would be a mess. But, I mean, that's why it's probably good that only about 70% is switching sexes and the rest are fixed.
Yeah, otherwise it could be a little bit awkward.
Exactly.
Thanks so much and welcome to the team, Sophie.
Thank you.
Christy, here's a good news story for you. AI has developed a battery that uses 70% less lithium than standard lithium-ion batteries, which could be a really big deal, especially for lowering the environmental footprint of electric vehicles and other devices.
And less expensive if I remember my lithium-onomics, right? But how do you do all of this with AI?
Always about the money. Let me start with the battery itself. So it uses a new material that replaces a lot of the lithium in a normal battery configuration with sodium, which just on its own is a pretty neat way to make a battery electrolyte a crucial part of a battery. And that could open up new questions about the basic physics of batteries on its own.
No big deal there, just questioning basic battery physics. And you said AI helped create this, so how did that work?
Right, so a team at Microsoft started with a dataset of millions of candidate materials that would involve swapping out lithium for other elements. The algorithm they used then eliminated anything that might be unstable and where the chemical reactions would just be too weak. Add in a bit of human expertise and machine learning, and they winnowed it down to just a couple hundred materials. And then a few battery experts had a look at those and narrowed it down to a single AI-suggested material to actually try to make. And then just 9 months later, they were lighting up a light bulb with this new lower lithium battery, which is pretty cool.
That's really fast.
I will add, though, that while this is a promising way to help material scientists figure out where to focus their efforts, there may still be some pretty significant obstacles in doing this in every setting. For example, the data needed to train such an AI can be fairly hard to come by. And for anything more complicated than battery components, this approach might just not work at all.
Well, how about some more good news?
Yes, please.
We have an update this week about the fate of amphibians threatened by skin-eating fungal diseases. This is the fungus known as BD that has been decimating hundreds of species of frogs and salamanders and has contributed to the extinction of many others.
And contributed the phrase the frog apocalypse,
Yes.
or sometimes amphibian apocalypse, because it's not just frogs. This is exactly the sort of thing I would like to hear some good news about. What have you got?
All right, well, here it is. Researchers in California's Sierra Nevada mountains have had success establishing populations of fungus-resistant frogs, specifically 2 species of mountain yellow-legged frog. They were actually already working on reintroducing these species to their historic range, because before there was a fungus problem, there was an invasive trout problem that had wiped out huge numbers of these frogs. But because the researchers were already in the middle of this project when the fungus appeared, they could look for resistance to the fungus in those remaining populations. And then they focused on reintroducing those frogs to the new habitat.
How do they know that the frogs are actually resistant to it, though? Couldn't it have been chance or something else keeping them alive?
That's a really fair question. And the team did analyze the genomes of frogs from seemingly resistant populations. They had some key differences in genes associated with the immune system, which very much suggests that these populations evolved in response to the fungus. More importantly, the reintroduction of these resistant frogs into new sites seems to be working. Since the project started 15 years ago, 9 of the 12 reintroduction sites have reproducing populations of frogs. And about half of those sites have populations with a greater than not chance of surviving for at least another 50 years, which is a very technical biological estimation process. And this is a very rare bit of good news in a very bleak landscape for amphibians around the world.
Amazing. So really they're harnessing something that the frogs were doing naturally, but then helping it along.
Yes, exactly. So in biology terms, this is what's called evolutionary rescue. We're taking advantage of evolution that's already happening and making sure it actually supports survival.
Nice. And speaking of survival or preservation, I've got a story from the Department of Implausible Fossils, and it's the discovery of the oldest ever fossil skin, nearly 300 million years old, and probably from a lizard-like species that's now extinct.
I can't imagine that we've got a particularly extensive global collection of fossil skin that this is adding to.
I've got my own personal collection of fossil skin, but other than that, you are right. In fact, this new skin is 20 million years older than the second oldest fossil skin, really sort of emphasizing just how little we have in terms of fossilized skin. We just don't find it that often. As you might imagine, skin is not very durable over long periods of time, and it usually decays before it can go through the fossilization process. But researchers at the University of Toronto examining tiny fossil fragments concluded that what they had in their hands, especially since it had the pebbled, scaly texture that you might see on a crocodile, was in fact fossilized skin.
If skin is so hard to fossilize, which makes a lot of sense, how do they think this skin got so well preserved?
Well, this fossil was found in a limestone cave in Oklahoma, which was full of oily clay and very low on oxygen. And so the reptile may have originally just kind of fallen down a hole, but both of these factors could then have slowed down decay enough that the skin mummified and then fossilized, which is good news for researchers who are trying to understand when skin evolved in the first place, that they've now got this specimen. As the older we can find evidence of skin, the earlier it likely came about.
And if that wasn't enough, one quick thing before we go. If you were getting psyched about 2024 being the year of the moon, as Leah Crane was so excitedly reporting last week, well, a few condolences are in order. First, the private space company Astrobotic is giving up on landing their Peregrine craft on the moon this month, thanks to a fuel leak. Even though the launch itself went smoothly, they say the lander has lost too much propellant for a safe descent.
And NASA is pushing back the timeline for sending humans back to the moon. The Artemis 2 mission, the one that Christina Koch will be on, was supposed to launch late this year and circle a human crew around the moon. But due to safety concerns with the spacecraft, NASA say that they're now looking at September of next year, 2025, for that step.
And that's it for this week. Thank you so much for listening. You can find all the stories we talked about today in the show notes, and you can subscribe to this podcast on whichever app you're listening on.
Plus, if you like the great stories we're bringing you, please give us a rating or review on Spotify and Apple Podcasts. It really does help us get into more people's ears. We'll be back next week. Bye for now.
Bye.
This podcast is produced by OG Podcasts. Find out more at ogpodcasts.co.uk.